Hello everyone. We're going to do an example from section 2.3. This one is asking us several things, so I picked this one because it's going to go through multiple parts. The first question is talking about using the leading coefficient test to determine the graph's end behavior. So the leading coefficient test is based on the first term. Now you got to make sure your polynomial's in order from highest exponent down to lowest exponent. And then your first term is how we're going to determine end behavior. So with this first term, I see that we have an even degree, and I see that we have a negative leading coefficient. So if it is an even degree function and a negative leading coefficient, that means our end behavior is going down on both sides. We don't know what's happening in the middle yet, but we know it's going down on both sides. So in your book or in the videos on the Moodle page, there are notes about the different scenarios. It's all based on whether it's even or odd and whether the leading coefficient's positive or negative. So this one falls left and falls right. The next question says to find the x-intercepts. This is very important. This will either involve factoring or quadratic formula or some combination involving all of that. So I'm going to write the function down. So to find x-intercepts, that means y equals 0. So we set the function equal to 0. Okay, for x-intercepts, we set it equal to 0. So this is kind of a special case. We only have two terms, and our only option really is greatest common factor, or GCF. So the greatest common factor between the two terms seems to be x squared. But I'll tell you something. If my leading term is negative, I almost always factor out the negative because it's going to be easier to have a negative somewhere else in my polynomial than it is in that first term. So I factor out negative x squared. So if I divide out negative x squared from negative x to the fourth, that leaves me with positive x squared. And we can tell I did that right because if I multiply these, I do get negative x to the fourth again. And if I divide out a negative x squared from 36x squared, that changes the sign to negative, but now it's just 36 because I divided out the x squared. Okay, so x squared minus 36. Okay, well this can actually be factored one step further. If I have a perfect square subtracting a perfect square, I can factor that again with difference of squares. The type of factoring, difference of squares. It only works when you are subtracting a perfect square from a perfect square. That was not supposed to connect right there. Okay, so the way difference of squares works is we factor it into two parentheses. Everything else will still be there. And it's going to be x and x, because that's the square root of x squared. And it'll be 6 and 6, because that's the square root of 36. And one's a plus and one's a minus. That's always how the factoring will work if it's subtracting perfect squares. Once you get it totally factored, you're going to set each piece equal to 0. Each piece with a variable gets set equal to 0. So then we solve each of these. If I divide by the negative, that's still 0. If I square root it, that's still 0. So this is x equals 0. I subtract the 6, I get x equals negative 6. And I add the 6, so I get x equals positive 6. Now, I could have done that at this step. I could have split it here, and I would have had x squared minus 36 equals 0. And then I would have added the 36. And then I would square root both sides. But I have to remember when I square root both sides that I need a plus or minus the square root. So you still get positive 6 and negative 6. But sometimes I think it's easier to see that it's supposed to be two answers when you factored it further. Sometimes people forget the plus or minus and then they're missing one of their answers. So my x-intercepts are 0, negative 6, and positive 6. At which zeros does the graph of the function cross the x-axis? So for it to cross the x-axis, it has to have an odd multiplicity. Multiplicity meaning how many times does that factor show up in the polynomial. So for example, the factor x plus 6 only shows up once. This factor is only there once, okay? The factor x minus 6 only shows up once. So they have a multiplicity of 1 because they only show up one time. Now, the x, this factor, this guy, actually is technically there twice. Because it is squared, remember being squared is just multiplying by itself. So really that's negative x times x, okay? That's the negative x squared. So it is showing up 2 times. X is showing up 2 times. So that is a multiplicity of 2. Showing up 2 times. So for it to cross the x-axis, we need it to have an odd multiplicity. So that's only going to happen at negative 6 and positive 6. For it to touch the x-axis and turn around, it's going to have an even multiplicity. So that's happening at 0. Oops. All right, the y-intercept, that's nice and easy. For the y-intercept, we just have to plug in 0. Instead of setting it equal to 0, we plug in 0. So it's negative 0 to the 4th plus 36 times 0 squared, and all of that ends up being 0 because that's 0 and that's 0, so it's just 0. So that's nice, that made it easy. Okay, determine the symmetry of the graph. Well, I can tell that both of my exponents are even. So that makes me think it's going to be an even function with y-axis symmetry. I can double check if I'm not positive by plugging in a negative x. I'm going to try and squeeze this in here. So if I plug in a negative x, everywhere there's an x. Whoops, I forgot the 36. Hold on. And the idea is if I end up with what I started with, my original function, then it's even. So the negative here raised to the 4th power becomes positive, and then I'm left with just this negative out here. So I have a negative x to the 4th. And again, this negative raised to the 2nd power becomes positive, so I'm left with just the positive 36x squared. Anytime you have even exponents, it's going to be an even function. If they're all even exponents, it'll be an even function. Okay? And the last question here is asking us to determine the graph. And this is super easy. You do not have to drag out your calculator, okay? We know that it needs to be pointing down on both sides. We know that it needs to cross at -6, cross at 6, and it needs to touch and turn around at 0, okay? There's only one function that does that. Not to mention the y-intercept needs to be 0. Okay? So this one does not cross at -6 and +6. Not going to work. Okay? This one I can already tell does not have a y-intercept at 0. Right? Y-intercept at 0? No. Y-intercept at 0? Maybe. But it's not doing the 6 and the -6, right? The only one that has the requirements that we have listed over here is this one. It crosses at -6, it touches and turns around at 0, which is also the y-intercept, and it crosses at +6. The end behavior are both pointing down. This is the function we want, and we did not have to type it in our calculator to see that. If you notice, the window's really big. It would have been annoying to try and graph it in the calculator. So it's better to use the information we've already figured out to choose the graph that fits. So it's D. Okay? And that's the end of that question. So if you have any questions, let me know. Otherwise, this is the end of this video. Thanks.